All right.
I got like 12 to the 2/3.
So let's try the Lagrange multipliers way to do. What did we want? We wanted 3 numbers that multiply to 6.
Yeah.
Yep.
Okay, so x times y times z is 6. And
But whose
Then you
sum
want
is
some
S of
part.
X, Y, and Z.
okay, s of x, y, and z, perfect.
Whatever you
Sum,
want.
good, is x plus y plus z, right?
Yeah.
And I want to, what do I want to do with s?
You want to make it as small as possible.
Yeah, I want to make it as small as possible, which should say in your head, minimize this. So we have 2 ways to optimize, right? You could solve this thing for one of the variables, substitute it in there, get some horrible little thing that you could try to find the derivatives of, and then set equal to 0 and find the critical points, and then
First
fiddle
time I did
around
well.
calculating the second derivatives.
The second time I did worse.
Yeah, that one's going to be horrible, right? The Lagrange multipliers way is probably pretty easy. So, what's the gradient of f and s, and what's the gradient of your? What do you call this thing?
Let's call it P.
Sure.
Constraint.
Yeah, I'd call it k for constraint, but call it whatever you want. So, what's the gradient for s? Yeah, 1, 1, 1. Right? No variables, which is why Lagrange multipliers is easy, right? Usually there are fewer variables involved. And then gradient of p,
YZ,
YZ,
Yeah,
XZ,
XZ,
comma,
and Y.
oops, xz, and xy. Okay, then what?
Set those equal to lambda. So
So
gradient,
gradient
S
S
equals
equals
lambda.
lambda gradient G.
Yeah.
Sure.
Wait,
Whatever
wait.
floats your boat.
It doesn't matter, right?
Either way.
Okay, so
Wait, so
put the
that's-
lambda on one side or
okay,
the
yeah.
other, set these 2 gradients equal to each other with a
Just
constant
lambda
multiple,
equals
right?
lambda.
So the reason I did it this way is that now I'm going to have 3 equations that are pretty easy, right?
These are all lambda.
Lambda is
1 over YZ.
yz, it's also xz, and it's also xy, right? See that? Okay, so out of that information, let's see, there's a green pair
X equals Y. And Z can equal
and a blue pair. Out of the green, you get what?
that. You get Y.
You get Y equals X.
You get y equals x, or I didn't see a lot of ors on these,
Z
so.
equals 0.
Or z is 0. What does z is 0 mean in terms of your sum and product?
It's 0.
Can't have.
Yeah, this ain't gonna
The
happen,
product would be
right?
0.
Because this would mean that x times y times z is 0, not 6, right? So you can toss that, but it would be good if you wrote that down. And then out of the blue, what do you get?
Z equals Y.
Yeah, out of the blue, you get z is y, or
X equals 0.
x is 0. And this one has the same problem, right? It's an extremely loud
Their
thing.
National Guard training, like 3
Oh, good.
weeks.
That'll be fun.
The next 3 weeks of class, though.
I'd rather have that than forest fires.
Taking pictures of black
That's
holes.
true. Ooh, helicopter. All right, what do I do with this information? Yeah, so far here I've found, right, that all the variables are the same, right? Specifically because y is usually y. Okay.
So X cubed equals 6.
Don't ask. Look at Donald's paper.
What?
All right, so in the end here, right, I have x cubed is 6.
Right above us.
Guys, go over Look at the people. All right, So x cubed is 6. What do I do with this information?
Solve for x.
Solve for x, right? So again, x is the cube root of 6. You need plus or minus this?
No, because you said in the instructions
Show plus
to
or
find
minus.
3 positive numbers.
The instructions call for 3 positive numbers. Even if they didn't, would I need plus or minus?
Cube.
No, it's a cube root. Okay, so I got x is cube root of 6. So what about y and c?
Equals y.
Right, they're all cube root of 6. Cool?
Let's see how Steven did his.
Very complex.
Yeah, I saw a couple that kind of wandered around a little bit. Solving these things, right, gets a little wandery if you don't see, okay, like, this is the way to do it. If you try to solve for one of the variables, everything gets really wandery fast. All right, how do I know this is the minimum? None of you did this justification. You should have. You should have spent a minute thinking, why is this the minimum?
I totally forgot how it
So this thing's definitely either, well, it could be a min, it could be a max, it could be a saddle, and you should have some kind of geometric something.
But you plug it into it.
Can you just say that since that's the only answer?
Yeah,
that
we
you
could take the
got?
second derivative, or we could say since it's the only answer, right, other than zeros, and zeros are clearly making that.
Not
That would be our
happen.
maximization.
Well, that still wouldn't be proof that it's a minimum, though. Right? Just saying it's the only one.
So
Well, if
just
the
saying
second
it's the only
derivative
one
is
isn't
zero.
quite enough, but saying that in any of the other directions it gets bigger would be enough, right? So I would really want to check, okay, so there's z is 0, x is 0, and y is 0. Geometrically, what do those say about s?
0.
Yeah, s would be, oh wait, this would be 0, right? What if I just went close to 0 in one of the variables?
The other two would have to be incredibly large.
Yeah, one of the others at least has to get incredibly big, or maybe both of the others have to get big,
So the sum
which
would
forces
be
the
big.
sum to get really big, right? So that would be my justification. Be if you run out towards these, your s is going off to infinity. Cool? Again, it's not perfect justification, but it is better than nothing. Cool?